I want to start today with a little thought experiment. It's a bit of a weird one, so bear with me. I want you to close your eyes, assuming you weren't driving, of course, and just visualize the machinery of your own mind.
The machinery.
Yeah, the actual engine room. When you make a decision, like, choosing to listen to this deep dive instead of, say, 80s pop hits, what does that look like inside? Do you picture a clean, high-tech control room, maybe a CEO sitting in a leather chair, looking at monitors, sipping coffee, and making a calm, rational choice?
That is the classic image, isn't it? The captain of the ship.
Right. But here's the alternative. What if you picture a rowdy, crowded stock exchange floor? Just a room full of people screaming over each other, waving papers, fighting for the microphone.
A total riot.
Exactly, a riot. Until finally, one guy shouts loud enough that everyone else just sort of gives up.
It is a terrifying image, honestly. But if we're looking at the research we have in front of us today, that second image, the riot, the pandemonium, is probably a lot closer to the truth of how intelligence actually works.
Which is a little unsettling. But it's the premise of the paper we're diving into today. It's called A Pandemonium Can Have Goals. It's by Giovanni Pezzullo and Gianguglielmo Calvi from the Institute of Cognitive Science and Technology in Rome.
This is a really fascinating piece of work. They're presenting an open source framework called AKIRA. And the big question they're trying to answer is, how do you get complex, smart behavior like planning a route or solving a problem without a master program telling the system what to do?
How do you get order from chaos?
Exactly. How does intelligence emerge from a mess of competition, noise, and limited energy? Because that's the thing. Biological brains are messy. They aren't clean code.
Now, before we get into the nuts and bolts, or I guess the demons and blackboards, you mentioned this fits into a specific debate in AI history, something about hybrid architectures.
Right. So broadly speaking, there have been these two big tribes in artificial intelligence. On one side, you have the symbolic tribe. They love logic.
Yeah.
Rules. If A happens, then do B.
Okay. Very clean, very top-down, like a flowchart.
It's extremely. But it's rigid. If something happens that isn't in the flowchart, the system just breaks. On the other side, you have the connectionists. These are the neural network people. They model the brain's neurons. It's messy. It learns from data. It's bottom up.
That's the modern ChatGPT style stuff, right?
In a sense, yes.
Yeah.
It's very flexible, but it can be hard to control. You don't always know why it does what it does. AKIRA, the framework in this paper, is trying to be a bridge, a hybrid.
So it wants the flexibility of the neural network?
With the planning ability of the logical system.
Yeah.
And the metaphor they use to mash these worlds together is the pandemonium.
Which, let's be honest, is a fantastic name for a scientific concept. The Pandemonium. Sounds like a heavy metal band.
It does. But it actually goes back to a researcher named Oliver Selfridge and later Jackson. And the core idea is that the mind isn't a single processor doing one thing at a time. It's made up of demons.
Demons. And just to be super clear for everyone listening, because we got this question, we aren't talking about supernatural monsters here. We are not exercising the AI.
No. Although the behavior might seem a bit possessed sometimes. In computer science, a demon is just a background process. It's a small agent that runs a specific task without you really, interacting with it directly.
But in the AKIRA framework, they're a bit special.
They are. They're microagents.
Yeah.
And their defining characteristic is that they shout.
They shout.
Computationally speaking, yes. They shout to get attention. Imagine you have a demon for hunger. You have one for curiosity. You have another for, did I just see something move? They're all running in parallel, all at the same time.
And no boss.
Initially, no boss. No CEO telling the hunger demon to be quiet. They're just snippets of code competing to be heard.
Okay, but that brings up a logistical question. If everyone is shouting, where are they shouting at?
There is a room. It's called the blackboard.
The blackboard.
Think of it as a shared memory space. Technically, in the framework, it's an XML stream. But the metaphor of blackboard in a public square is perfect. If a demon detects something, say the vision demon sees a red blob, it runs to the blackboard and writes, I see red blob in big letters.
Okay, so then the other demons see that.
Exactly. And this is the crucial part. The hunger demon might look at the blackboard, see red blob, and think, hey, apples are red blobs, I'm interested in this. So the hunger demon starts shouting louder.
But wait, if there's no central interpreter, no little man inside the brain reading the blackboard who decides that the hunger demon wins.
That is the magic trick. The intelligence of the system comes purely from the volume. It comes from who is shouting the loudest and how that activation spreads to other demons.
So no one decided to eat the apple.
No, The shouting just reached a critical mass that triggered the Reach with Hand demon.
It feels so chaotic. I mean, efficient maybe, but chaotic. It sounds like a system that would overheat immediately. If I have 1,000 demons all screaming at top volume, wouldn't the computer just freeze?
And that is exactly why the next part of the paper is so important. Because you're right, if every daemon ran at full power all the time, the system would crash. So the authors introduce a constraint that makes this AI feel incredibly biological.
The energy pool.
The energy pool.
This was the part that really clicked for me. Usually when we think of software, we don't think about fatigue. My spreadsheet doesn't get tired. My word processor doesn't say, I'm out of breath, I can't spell check right now.
Right. Software usually assumes infinite resources until the battery dies or the RAM fills up. But in AKIRA, energy is a programmed finite resource. The authors call it an energetic metaphor.
How does that work in the code?
Basically, activation level equals energy usage. If a demon wants to shout, it has to pay. If it wants to run a complex calculation, that costs more. And all the demons are drawing from a single shared pool of energy.
So it's a zero-sum game.
To an extent, yes. If the fear demon is screaming because you see a snake, it is draining a massive amount of energy from the pool. That means there is literally less energy available for the do mental math demon.
Or the remember song lyrics demon.
Exactly.
Which explains why I can't multiply big numbers while I'm being chased by a bear.
Precisely. It forces the system into what's called homeostasis. It always tries to stay balanced. Demons borrow energy to act, and when they're done, or if they realize they aren't relevant anymore, they have to release that energy back to the pool.
It's a resource economy.
It is.
Okay.
It changes how you view attention. We think of it as a spotlight we choose to shine. But this suggests attention is just budget management.
It's the survival of the fittest thoughts.
The demons in your head are literally fighting for the fuel to exist. If a demon can't get energy, because no one is listening to it, it dies down. It goes silent.
There was another concept tied to this, a really visual one they borrowed from Douglas Hofstadter, the idea of temperature.
Yes, Hofstadter's work is a huge influence here. They use temperature to describe the state of the whole system, like how chaotic is the room right now.
A hot system versus a cold system.
Right. Imagine you're trying to solve a jigsaw puzzle, and you've just dumped the pieces on the table. You have no idea what goes where. You are grabbing pieces, trying them, tossing them aside, moving your eyes rapidly.
That's a hot system.
That's a hot system.
Oh.
High energy, rapid shifting, lots of mistakes. It's quick and dirty computation because the system detects it's far from a solution. So it tries many hypotheses very, very fast.
And then cold is when you find the corner pieces.
Exactly. As patterns start to emerge, as the corner demons start agreeing with the edge demons, the system cools down. It becomes stable, conservative. You stop trying random things because you have a working theory.
I love that phrase from the paper. Confusion is hot, understanding is cold.
It really maps to the human experience, doesn't it?
Yeah.
Learning something new feels hot. It's exhausting. Your brain feels buzzy. Doing something you know how to do feels cool. It's smooth, low energy.
Okay, so we've got the shouting crowd, the pandemonium, and we've got the budget, the energy. But if I'm just a collection of shouting microagents, how do I ever do anything complicated? How do I, plan a vacation? You can't just shout a house into existence.
That is the million-dollar question. How do you go from chaos to order? In AKIRA, the answer is that the demons form coalitions.
Coalitions, teams.
Teams. But the paper distinguishes between two very different ways these teams form. And this goes back to that hybrid idea we started with. There are bands and there are hordes.
Let's start with bands. That's the bottom-up one.
Yes. Think of a band like a crowd spontaneously lifting a car off someone. There was no meeting beforehand. A demon starts shouting for help. Maybe he has a task he can't finish alone. Other demons join based on similarity or proximity.
Proximity, like linked concepts.
Yeah, exactly. AKIRA uses a linked list, sort of like a neural network. If I activate the dog demon, the concept of bark or fur is logically close by. So dogs start shouting bark might naturally join the band. It is auto-organization.
It sounds very organic, very improvised.
It is. But sometimes improvisation isn't enough. If you're building a skyscraper, you can't just rely on people showing up and doing whatever they feel like. You need a plan.
And that's the hordes.
That is the horde. And I admit, horde sounds chaotic, but in this paper it's actually the structured one. A horde is led by a special type of demon called an archon.
An archon sounds very sci-fi.
It's almost medieval. An archon is like a project manager. It carries a skeleton, a blueprint. It has a plan, but the plan has empty slots. It needs to recruit other demons to fill specific roles.
So instead of, hey, everyone come help, it's I specifically need a plumber, an electrician, and a roofer.
Precisely. The Archon recruits specific functions to fulfill a hierarchy. This is the symbolic, logical side of the AI coming into play. The Archon says, I have a plan to hunt prey. Slot A is track, slot B is chase, slot C is bite. It then looks for demons to fill those slots.
So AKIRA is running both of these at the same time, the improvised jazz band and the strict orchestra.
Yes. And they're competing for the same energy. That's the beauty of it. Depending on the situation, the system might shift from a rigid horde to a loose band if things go wrong. If the Archon's plan fails, the energy dissipates and the bands take over again.
I want to ground this because abstract demons are fine, but the paper gives a really specific example that I found incredibly helpful, the watchdog.
Ah, yes, the watchdog simulation. This is the real aha moment for understanding this architecture. It shows how behavior emerges without a central brain telling the agent what to do.
Okay, walk us through it. We have a robotic dog or a simulation of one.
Right, and this dog has what we call a norm and a few goals. The norm is a maintenance condition. Stay close to the house. It always exerts a pressure to be near home.
Okay, and the goals.
Goal number 1, walk around the house. Goal number 2, bark at an intruder. Goal number 3, chase the intruder.
Simple enough. But these goals conflict. You can't stay close to the house, and you chase the intruder if the intruder runs away.
Exactly. Now, in a traditional old-school computer program, you would handle this with a massive if-then chart. You'd code, if intruder distance is greater than 50 meters, then stop chasing. You, the programmer, have to predict the conflict.
But AKIRA doesn't do that.
No. In AKIRA, the programmer just creates the pressures. Imagine them as physical forces or vectors. The chase goal exerts a pressure to move away. The norm stay home exerts a pressure to pull back.
Like a rubber band attached to the dog's collar?
Perfect analogy.
Yeah.
So the intruder appears. The chase demon sees it and shouts really loud. He gets a huge burst of energy. The dog runs. The rubber band stretches.
But as it gets further away...
The norm demon starts shouting louder and louder. We are too far. We're violating the norm. The further the dog goes, the more energy the norm demon gets because the violation is getting worse. It becomes a tug of war.
So the dog chases until...
What? Until the pressure from the norm becomes mathematically stronger than the pressure to chase. Then the dog naturally turns back.
And the key here is that the dog didn't decide to turn back.
Right. There was no specific line of code that said turn back at 50 meters. The behavior emerged from the competition. It was a dynamic resolution of forces.
That seems safer in a way. If you forget to program the stop command in a traditional AI, the dog just runs forever. Here, the home rubber band eventually wins no matter what.
Exactly. It makes the system robust, just balances the forces and acts. And the paper mentions the complexity can grow from there. The norm might trigger a new goal, like go home immediately, or activate a whole new plan.
But fundamentally, the base behavior is just these conflicting vectors fighting for energy.
Yes.
This brings us to a really deep question, though. If the dog is just reacting to these vectors, does it know anything? Does it know there's an intruder? Or is it just that the bark demon is currently winning the shouting match?
This gets into the section on epistemics, which is just a fancy word for how the system acquires knowledge. The authors argue that in AKIRA, seeing isn't passive, perception is an action.
Perception is an action. What does that even mean?
It means you don't just receive data like a camera recording a video. Agents ask questions to the environment based on their current goals. If the dog is hungry, the hunger demon biases the visual system. It's actively scanning for food-related patterns, shapes, colors, smells of food.
So it's not paying attention to the color of the curtains.
Not at all. It filters the world through its goals. It only sees what matters to the loudest demon.
And from that, it builds belief.
Precisely. The paper calls them epistemic atoms. A belief is a constructed piece of information, like there is an intruder. But in this framework, that belief has a degree of certainty attached to it. It's not binary, not yes, no. It might be, I'm 80% sure there is an intruder.
And how does it get to 80%?
By polling the sources. The belief demon checks the blackboard. Did the vision demon post a sighting? Did the sound demon post a noise? If 3 different demons are all shouting about an intruder, the certainty goes up. It constructs its reality from the evidence on the board.
One thing in the paper that really blew my mind was this idea of introspection. Because if there is no self, no CEO in the control room, how does the system know what it's doing? How does it know I am chasing a cat?
This is my favorite part of the theory. It goes back to the blackboard. Remember, Demons post their actions publicly. Introspection in AKIRA works because some agents are specialized just to watch the blackboard.
Wait, so they are spying on the other demons?
In a way,
Hmm.
the paper calls it Pandemonium without Satan. There's no master evil genius, but there are demons whose only job is to look at the public activity of other demons. They can't see the private memory of those agents. They can only see what they post.
So a self-monitored demon might look at the board and see legs running, mouth barking, eyes focused, and it concludes, oh, look at that. We must be chasing something.
Exactly. It creates a narrative. It allows the system to monitor itself meta-reasoning without needing a central self module. The self is just another story the system tells itself based on the shouting of the crowd.
That is profoundly disturbing and also incredibly cool. It suggests that consciousness might just be the sports commentator describing the game, not the coach calling the plays.
It's a very strong argument for that view. And it bridges this gap we've struggled with. Logic programming is too rigid. Neural networks are too messy. AKIRA is saying, let's have the structure of logic, the hordes, but drive it with the energy and competition of the neural network.
It creates a system that has urgency. That's what I took away from it. Real cognitive processes feel urgent. We feel pressure to act. This system simulates that pressure through energy costs.
And that is vital for survival. You don't have time to calculate the perfect chess move when a tiger is chasing you. You need a hot system that throws out a quick and dirty solution immediately.
So to wrap this up, AKIRA creates a society of mind. It uses the BDI model beliefs, desires, intentions, but it builds them from the bottom up.
Correct. Complex, goal-directed behavior isn't the starting point. It's the finish line. It emerges from these simple demons competing for limited resources.
It really forces you to rethink what goals even are. We think of a goal as this noble, defined thing we strive for. But in this model, a goal is just a demon that managed to shout louder than the laziness demon for long enough to get the job done.
And once the job is done, that demon stops shouting, releases its energy back to the pool, and the next loudest voice takes over.
So here's the final thought I want to leave you with today. We talked about the dog. The dog chases the intruder not because it decides to, but because the vector of the chase is stronger than the vector of the house.
Right. It follows the energy.
Think about your own day-to-day. You got up, you went to work, you ate lunch, you chose to listen to this deep dive. Did you, the CEO, make those choices? Or are you just a pandemonium of shouting demons, and what you call your will is simply the noise made by the demon that won the energy war 5 seconds ago?
It raises the question, are our goals actually ours, or are they just the loudest shouters in the room?
Something to think about the next time you change your mind for no reason.
Thanks for listening to The Deep Dive.
See you next time.